How can you write a quadratic equation when a and c are missing? Let's find out. So we're going to look at three separate examples here. One where we want our quadratic to have two real solutions, one where we want our quadratic to have one real solution, and one where we want our quadratic to have two imaginary solutions. So let's jump in. Example 1 says, find a possible pair of integer values for a and c so that the equation ax squared minus 12x plus c is equal to 0, has one real solution, and then write the equation. So keyword here, or phrase, is one real solution. So that should tell us the discriminant should be equal to 0. So now we can take b squared minus 4ac, and we can set that equal to 0. We know it has to be equal to 0 because we want there just to be one real solution. So now we know that b is negative 12, so we could plug that in. So negative 12 squared minus 4ac is equal to 0. So this would give us 144 minus 4ac is equal to 0. And now let's move this 144 to the other side. So we'll come up here. So now we have negative 4ac is equal to negative 144. And let's divide both sides by negative 4. So now we get a times c is equal to, and we can do 144 divided by 4, and we get 36. Okay, so now at this point right here, we have options. We just need a and c to multiply to 36. So you could use 1 and 36, you could use negative 1 and negative 36, 2 and 18, 9 and 4, 3 and 12. It really doesn't matter, right? We have options here. So let's just say a is equal to 9 and c is equal to 4 just to make it easy for us. And so now we just take 9 and 4 and we plug those in for a and c, and we have our equation. So we could say our equation could be 9x squared minus 12x plus 4 is equal to 0. And this equation would give us one real solution. All right, so let's take a look at example 2. Now it says find a possible pair of integer values for a and c so that the equation ax squared plus 3x plus c equals 0 has two real solutions. So key here is two real solutions. So now we know that our discriminant just needs to be a positive number. And so here we can kind of play around with it a little bit just to make our numbers easier for us to work with. So for right now, let's just say b squared minus 4ac is equal to, this just needs to be a positive number. Okay, so I'm not going to put a number in there yet. I'm going to wait just a second. So now I know that b is 3, so we have 3 squared minus 4ac, and 3 squared is 9, right? Okay, so now I know in order to solve this, I'm going to subtract 9, right, from both sides, and then we're going to divide by negative 4. So let's just try and think of a positive number that when we subtract 9 and then divide by 4, we still have a whole number or an integer, something easy to work with where we don't have to work with fractions or decimals. So if we divide by 4, obviously we want something divisible by 4. So let's think about, let's do 24, okay? So now 24, and then let's add 9 to that, and we're going to get 33, okay? So let's just say this is equal to 33. Okay, and the reason we're doing that is so that this makes it easier for us. And 33 is fine because it just needs to be a positive number, right? Just any positive number. So now we do 33 minus 9, so we get negative 4ac is equal to 24. And now let's divide both sides by negative 4. Okay, so now we get a times c is equal to negative 6. So now that just tells us that a and c need to multiply to be negative 6. So let's just use negative 3 and positive 2. And it doesn't matter here. Let's just say a is negative 3. And c is a positive 2. So now we can use these two numbers to write our equation. So let's say negative 3x squared plus 3x plus 2 is equal to 0. And that would be an equation that would give us two real solutions, right? And you could take that and graph it in your calculator just to verify that that's true. All right, our last example. Now we want to find a possible pair of integer values for a and c so that the equation ax squared plus 4x plus c equals 0 has two imaginary solutions. So this is going to be very similar to the one we just did. We just need this to now be equal to a negative number. So we have b squared minus 4ac. This just needs to equal a negative number. Okay, and once again, we can kind of choose whatever negative number we want so that the operations are easier. So we know b is 4, so we have 4 squared minus 4ac equals a negative number. So 16 minus 4ac equals our negative number. And now once again, we're going to subtract 16, and then we would divide by negative 4. So let's think about another number that's divisible by 4. So this time let's use 40, right? Let's just use 40. And so if we're going to take 40, it needs to be, that's the value that we want to end with, right? And so let's start with, let's say, what if we started with negative 24, right? Negative 24, and then we're going to subtract 16, right? So that's going to give us negative 40, okay? So now we have negative 4ac is equal to negative 40, and now we can divide both sides by negative 4. So we get a times c needs to equal, or needs to multiply, a times c needs to equal 10, right? So let's just use 2 and 5. So let's say a is 2 and c is 5. So now we would have 2x squared plus 4x plus 5 is equal to 0. And if we graph that, this would be a parabola that opens up, but its vertex would be above the x-axis. So there are two imaginary solutions. And that's how you can write a quadratic equation when a and c are missing, but when you know b, and you know the types of solutions that you need to have.